Hello everyone, in this video I'm going to discuss the topic limits and continuity. Here are the example for the continuity. A function of f is given as the function fx. So we notice that here we have the modulus of x plus 1. So before I further my discussion, I'm going to define the modulus of x plus 1. So modulus of x plus 1 is equals to x plus 1 where the domain is x plus 1 greater equals to 0. Next we have negative x plus 1 and the domain will be x plus 1 less than 0. So after we simplify the situation, we will have modulus of x plus 1 equals to x plus 1 x greater equals to negative 1. Next we have negative x plus 1 and the domain would be x less than negative 1. Next, I'm going to illustrate the situation of fx in the number line. So now I'm going to locate the value 0. Let's look at the first function, absolute value of x plus 1, where the x must be less than 0. So depends on the situation and the domain. So we can see that x less than 0. So where we have x less than negative 1. So in this part, again, we need to define. Here we have a negative 1. So if the value x less than negative 1, the function would be negative bracket x plus 1. For the situation x is greater and equals to negative 1, it will be x plus 1 and to the right if the value is negative 1. Next, we are going to define when x equals to 0, the function would be 2. If the situation x greater than 0, the function would be e to the power of negative 2x. So here will be our situation. So now we are going to answer the question. Question number 1. Find the limit when x approaching 0 from the left. Followed by limit when x approaching 0 from the right. And then find the limit when x approaching 0. So by referring to the number line, limits when x approaching 0 from the left. So by referring to the number line from the left, so our function will be x plus 1. So by substituting the value 0, our answer will be approaching 1. Next, limit when x approaching 0 from the right. The function would be e to the power of negative 2x. By substituting the value e to the power of 0, again, the value of y will be approaching 1. So finally, limits when x approaching 0 for the function fx, we will have 1, or we can say approaching 1. So next, hence, determine whether f is a continuous and x equals to 0. Give a reason for your answer. So when we discuss about continuity, first we have to refer to the condition. Condition number 1, f0. By referring to the diagram or the number line, when x equals to 0, the function will be 2. So the answer will be 2. f0 is defined. Second condition, limits when x approaching 0 for the function fx. So for this case, the answer is approaching 1 and it is exists. Condition number 3, limits when x approaching 0 for the function fx, is it equals to f0? So for this case, we have to refer limit when x approaching 0 for the function fx, the value is approaching 1. For the function f0, the answer is 2. So for this case, limit when x approaching 0 for the function fx does not equals to f0. So number 4, as a conclusion, fx is discontinuous at x equals to 0. So here we are, and thanks for watching.